Hi, I'm Steve Albini, and we're here in Studio A of Electrical Audio, and today we're going to talk about recording acoustic stringed instruments. When I talk about recording an acoustic instrument, what I really mean is recreating the sense memory of having heard an acoustic instrument. And I say that because acoustic instruments have an extremely long tradition. Every part of the world uses some form of acoustic stringed instrument, and we all have ingrained in us personal and cultural memory of the sound of these instruments. It's one of the most widespread shared cultural things is the experience of hearing an acoustic instrument in life. So when I say I'm trying to make an accurate recording of an acoustic instrument, what I mean is I'm trying to evoke the sensation of having heard that instrument in life. And that's one of the reasons why I prefer using microphones over pickups in a studio situation. Let me just explain slightly about the nature of acoustic instruments. So for all acoustic stringed instruments, there's the instrument body itself, there's a bridge, and there are strings. The strings transmit vibrations. These wiggly lines are meant to indicate vibration. The strings vibrate, and the bridge transduces that vibration. It transmits the vibration to the top of the instrument. This is the top of the instrument. And then the body of the instrument and the top of the instrument begin to vibrate and amplify the sound of the vibrating strings. So when you're listening to an acoustic instrument, the majority of the sound that you're hearing is the effect of the body on the sound. The string makes some sound on its own, but the system of the string playing and amplified by the mechanics of and the acoustics of the body, that's what we hear and what allows us to recognize the difference between one instrument and another. That's the reason we can tell the difference between a cello and a violin or a guitar and a banjo, is that the bodies are different and that this system creates a different cumulative effect and overall sound. This is for an instrument that you would hear acoustically. A pickup on an acoustic instrument typically is a transducer that's mounted under the bridge, inside the bridge plate, or in the case of a violin or cello, just wedged into the wood of the bridge. And then there's a lead that comes out of that transducer, and that takes an electrical impulse from the vibration of the bridge and allows you to amplify it. While that's useful, what this pickup does is amplifies the movement of the bridge, that is the initial sound of the string, and it completely ignores the whole rest of the system. The top of the guitar or the instrument, the air volume inside the instrument, the contribution of the back, the acoustic reflections formed by the shape of the instrument, the physical size of the instrument, the air that pumps in and out of the instrument through the sound holes. The entire rest of the mechanical and acoustic system of the instrument is completely ignored by this electronic pickup. So that's the reason that pickups tend to sound the same from one instrument to the next. There tends not to be that big of a difference in the sound, say, of a pickup on a $500 player's grade guitar or a $10,000 custom-made instrument. The pickup is doing the same work in either, and it's ignoring the quality that's built into the rest of the instrument. Now, in an amplified setting or in a setting where the sound quality of the instrument isn't critical, I think pickups have their use. They're very convenient for demo recording, for example, where you're just trying to transcribe an idea and you don't want to have to set up microphones. They're useful in an amplified electric setting, or if you want to use effects on your instruments to abstract the sound, for example. They're very useful in those contexts. In a studio setting where you're trying to create the experience of a natural acoustic setting, I think pickups are essentially useless. There are cases where isolation is a consideration, and we'll get into that next. So the title card for this one would read isolating the instrument from surrounding sounds or something like that. Isolating the instrument from the rest of the, isolating the instrument is probably isolating the sound of the instrument is probably the best title card. Isolating the sound of the instrument. There are a lot of settings for acoustic instruments where you need some degree of rejection of the outside sound of the ambient world, some isolation of the instrument, in other words. It could be that you have an electrified band that has some acoustic instruments, or you have a rock band where every now and again there will be an acoustic instrument introduced. Or it can be an ensemble that's entirely acoustic. Whatever the case, there is often a need to provide some isolation of an instrument. One very common scenario is a singer-performer where you have, say, a guitar player who's also singing a song simultaneously, and you're recording those two things simultaneously. You get very good synchronization between the singing and playing when they happen simultaneously. It often sounds much more natural than an overdub, for example, for either part of the music. And there are a lot of performers who record exclusively in this way, where they only do it that way, singing and playing simultaneously. So it's important to have some techniques that allow you some isolation between the vocal and the guitar, for example. If the guitar makes a mistake and you need to correct the music, if there is a significant amount of guitar bleed in the vocal microphone, then the ghost of that clam may still make its way into the vocal. Similarly, if the vocal take isn't great, but the musical take is good, and you want to replace the vocal, the ghost of the vocal in the instrument mic can cause problems later by interfering with the new vocal. It's most egregious in an improvised setting where the text and lyrics are going to differ from take to take. But even if it's just a matter of tuning, it can be a problem if the ghost of a poor vocal take appears in the instrument mic. So I have a diagram here of just that scenario of a guitar player who's singing simultaneously.
Steve, I thought we agreed that you weren't going to make your drawing so small.
I love the little drawings.
We emailed about this specifically.
And in that setting, you can use the directional pattern of the microphone to help you achieve some isolation. So here, for example, you can have a figure-8 microphone with its live side facing the vocal. That is, the active portion of the microphone, active part of the pattern, is facing the vocalist's mouth, and the dead side, that is the null of the microphone, is facing the guitar. Similarly, you can have a figure-8 microphone facing the guitar where its null is facing the vocalist's mouth. So you get, in this setting, you have one microphone that's favoring the vocal and rejecting the guitar, and another microphone that's favoring the guitar and rejecting the vocal. Let's head into the studio where I've assembled some fantastic musicians who will help us demonstrate some of these techniques. This is my friend Rob Bochnik, and in addition to being an outstanding musician, he helped build electrical audio. He was one of our first employees and one of our greatest employees. In a situation like this, where Rob is going to be singing and playing simultaneously, the interaction of the vocal and the guitar can cause problems for both the vocal and the guitar. All the sound is happening at the same time, so there will end up being vocal in the guitar microphone and guitar in the vocal microphone. To minimize that, we're using several different techniques. These microphones on the top of the guitar, attached to the top of the guitar, pick up the immediate sound of the guitar at a very, very close proximity. A lot of detail in these microphones. They aren't super full sounding though. They don't have a lot of low end in them because they're not hearing as much of the body movement and the air movement out of the sound hole. To pick that sound up, I'm using this external microphone. This is a Beyer M130. It's a bidirectional ribbon microphone. And bidirectional means that the polar pattern is a figure 8. It has a live side on the front, a live side on the rear, and a dead side on the side. And I have the dead side, that is the null, pointed at Rob's mouth. And that goes a long way toward minimizing the bleed of the vocal into the guitar microphone. Similarly, I have a figure 8 microphone here made by the company AEA, and its live side is pointed at Rob, and its dead side is pointed at the guitar. And that'll go a long way toward minimizing guitar bleed into the vocal microphone. So these two microphones on the top are attached with foam-backed, double-sided sticky tape. If you're concerned about the finish of your guitar, and you should be concerned in rare cases if it's a very old instrument that has a cracking or peeling finish, or if the finish is particularly thin and fragile, say if it's a shellac French polish and you've noticed that it started to flake up in certain areas, then this double-sided sticky tape may be aggressive enough that it could damage the finish. In those cases, you can take a piece of blue painter's tape and put it under the strings in the same location. Blue painter's tape has a very gentle adhesive. It removes easily without affecting any of the finishes that I've described. And then you can use the double-sided sticky foam tape to attach to the blue painter's tape. In this case, this is a modern instrument. This is a Taylor guitar. It has a very hard, modern cured finish on the top, so there's nothing to worry about. And the microphones will just peel right off when we're done with them. Okay, if you're cool, Rob, I'll go into the control room and we'll hear what it sounds like with you singing and playing. Okay, Rob, let's hear a song.
My good and me, you know we played along in the bread line, rolled out into the streets and the alleyways in the sunshine.
I'm going to mute the vocal microphone so we can hear how much vocal bleed there is in the guitar.
Penny or quarter sometimes.
Now I'm going to mute the guitar microphone. We can hear how much guitar there is in the vocal microphone.
She trusted me because I trust in her. But we still have a long way to go.
And here's everything again.
Yes, we still have a long way to go. Yes, we still have a long way to go. A way to go.
That sounded great.
Thank you.
So joining us is my good friend Alison Chesley, and she performs under the name Helen Money. She makes fabulous cello-based music, which we'll leave a link in the description for.
Thank you.
This is her cello and good friend Sparky. Can you tell us how you met Sparky and how long he's been in your life and yada yada?
Yeah, Sparky came into my life after the cello I had before. I would put it underneath in a very short trip going from Chicago to Minneapolis, and it got it was in a flight case, but somehow it got damaged, and I opened up the case and the cello was in splinters, and it was I loved that cello.
And this was in a van?
This was in an airplane.
In an airplane. So an airplane broke your cello.
Mm-hmm.
Okay.
So, so then I had a chance to get this cello. I worked at a violin shop, and so the guy at the shop sold it to me wholesale, which is the only way I could have afforded it. And the man who made it, his name's Peter Stozel. He's from Poland originally, and he's since passed away. But I love this cello. I love the sound. I can't imagine playing on anything else. And I play it even when I'm doing amplified because I just like the sound of it.
So one of the things I'm curious about with acoustic instruments is your relationship with your instrument is an intimate one. You play only this cello and you
Yeah.
played him for a very long time. And so you're intimately familiar with the sound of your instrument.
Right.
What have been some things that have been unsatisfying when you hear a recording of yourself playing your cello?
Well, I don't know that I could describe it like technically, but I feel like if it's too much high end, if it's not an, I think it's a balance between getting the nice, the air of the instrument coming out in the low ends, the low tones, and also some clarity. So I always feel like when I go into a studio, it's a bad sign when there's like a mic up here and there's a mic over here and there's like 3 mics, and I kind of feel like the best sound that I've heard from my cello is just a really well-placed mic in front of the instrument.
Well,
So yeah.
that corresponds with my experience as well. Like when I first started experimenting with recording acoustic instruments, I didn't know what I was doing, and so I tried a lot of elaborate techniques thinking that one of them would work. And in the end, what I've settled on is a very good quality microphone with a wide frequency response in a position where acoustically the cello sounds great. So like if you move your head around and you find a spot where the projection of the
Yeah.
instrument is really good and put the microphone there, and you know, don't be shy, use an expensive microphone. That's been a big difference for me. The choice of microphone will change the emphasis. So this microphone is a Josephson C617. It uses a Gefell capsule, which has an extremely flat frequency response. That is, this microphone is like very, very even in its response from the very high frequencies to the very low frequencies. So it's good for that thing that you described about having a balance between the detail and the low tones. Yeah. If you're in a setting where you want to emphasize the sort of beefiness or the low end of the cello at the expense of some of the crispness or the clarity of the notes, then you might use a different microphone. You might use a ribbon microphone, for example, which has a slightly smoother high end, but a little bit more present, a little bit more weight in the low end. But I've had the pleasure of recording you playing the cello many times, and we've, by experiment, we've sort of settled on this as a very good representation of your cello playing. In a setting where you have a bunch of ambient noise around you, where you have other instruments, your pickup could be useful for isolating your cello, but I have another technique that I want to try.
Awesome.
This microphone is one of a class of small, high-quality lavalier microphone. Lavalier? 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 Let's say lavalier. Microphones. This one is made by the Crown Company. It's called a GLM 100. There are many iterations of microphones of this type, small electret condenser microphones. Very good ones are made by Sony, Countryman, DPA makes an excellent one. There are many iterations of this style of microphone, and they can be attached kind of unobtrusively to the tailpiece of the instrument like this, which gives you a very close representation of the movement of the body of the instrument. It's close enough to the sound hole that it can hear some of the air moving from inside the instrument to the outside, and it's relatively close to the contact point of the bow and the string, so you get some good detail with it. I'm going to attach this microphone here with a little piece of gaffer tape.
Cool.
And now I'm going to go get the little piece of gaffer tape.
It's interesting what you said about this microphone, that it's flat. Because when I plug into a preamp, when I play amplified, I don't EQ it, I just run it flat. And that's how I get the best, I feel like I get the best sound.
Yeah, I mean that your tastes are what they are, and
Yeah.
that you like the actual sound of your instrument. You're not looking for like a goofy science fiction version of Sparky.
No.
Okay, let me make this a little smaller so it doesn't bite into your tuners. Okay. All right, we're going to go into the studio now and listen to the sound of Alison and Sparky. Okay, Alison, can I hear you play some? God, that microphone sounds so good. That sounded awesome.
Cool.
Okay, Alison, now we're going to do a sample using the dinky little microphone attached to your cello.
Okay.
Go ahead and play if you don't mind. That sounded terrific. Thank you. This is my friend Susan Voelz, and she has played on many sessions here at Electrical Audio. She's a phenomenal violinist and arranger, and I particularly love the sound of her violin. Do you want to tell us a little something about your violin and how you came to have it?
Yeah, this violin is a Vincentus Postilione violin from Italy, and my folks got it for me when I was I was 9. And they got it for $400, and it just got better and better in sound over the years. So now it's worth a good amount of money. And it sounds it's gotten warmer and warmer.
So do you have a nickname for him?
Vincent.
Vincent?
Yeah, Vincent.
Awesome. And when you have heard Vincent recorded, what about the sound has been unsatisfying to you? That is, what is the sort of thing that an engineer should be paying attention to when recording Vincent?
Yeah, when it sounds thin, brittle, not warm, tiny sounding, too kind of scrapey sounding.
So similar concerns to Alison, where she just wants like a natural, full representation of the instrument without like accentuating the like stringy or irritating part of the sound.
Right.
Yeah. So the microphone that I tend to use for your violin is this microphone. It's a Lomo 1918. It's a Russian microphone from the Soviet era, a vacuum tube condenser microphone. And the thing about it that is particularly nice is that in the high frequency region, like in the highest frequencies, it's quite smooth. The response doesn't have big spikes in the response. And that is a very difficult thing to do in manufacturing microphones, so consequently microphones that have that characteristic tend to be fairly expensive. I have not found very many inexpensive microphones that are super smooth in the high end and therefore like a good substitute. But a characteristic to look for in a microphone for recording violin is that is the high frequency response is very smooth. It doesn't have to be completely flat. So for example, the other microphone that I'm going to demonstrate on your violin is the STC 4038. It's a ribbon microphone, and the ribbon microphones don't have a particularly extended high frequency response. The high frequency response actually slightly rolls off. But as it's rolling off, it doesn't have these irregularities that I was describing, where one frequency will spike up quite a bit louder than a neighboring frequency. And that's precisely the sort of thing that the violin will reveal as a flaw or a weakness in a microphone's response. If the high frequency response is irregular, recording a violin will let you know about it very quickly. I'm going to go inside and we'll listen to this microphone, and then I'll swap it out for the other microphone and we can compare them.
Okay.
Okay, Susan, can I hear you play a little bit?
Yes.
That sounded great.
Thank you.
I'm going to replace this microphone, the Lomo 1918, with this microphone, an STC 4038. They're quite different. This is a tube condenser microphone, and that is a ribbon microphone. They have different sound qualities, and they're physically quite different. This microphone is pretty light. It doesn't have a lot of weight to the body, and there's not a lot of electronics inside. So I can get away with having it extended on a very long boom like this. But the STC 4038 is quite heavy. So in order to extend that onto a long boom, I have added a counterweight to this end of the boom. If I didn't have a counterweight here, this microphone's quite heavy, it's over a pound. So I would need to torque this joint down extremely tight in order to keep the boom from sagging. And that puts stress on all the metal parts, on all the resilient parts, and also puts the microphone and the player at risk because the microphone could easily come crashing down if there was a failure. Putting a counterweight on here balances out the weight, and it makes it easier for this piece here to hold the boom stable. Another consideration, whenever you have an extended boom like this, you should always make sure that one of the tripod legs of the stand is under the extended boom arm, because that makes it more stable in this direction. That's convenient when you're recording a violinist, because the extended leg can fit under the chair of the musician. Okay. So can I just see you play a little bit? I want to make sure your bow isn't going to be interfered with. Yeah, it should be good. All right, I'm going to step inside and see what this microphone sounds like. Okay, Susan, go ahead and play a little bit for us. Well, that sounded great as well. And I'm going to talk about the differences between the two microphones and why you might choose one or the other. This ribbon microphone does not have as extended of a high frequency response as the condenser microphone. So if you were looking for a softer or a smoother sound on the violin, that is less emphasis on the attack and the bowing and more emphasis on the extended tone of the instrument, then a ribbon microphone might be a good choice. If you were looking for precision and more detail in the violin, then the condenser microphone might be the better choice. One other subtlety, this is a figure-8 microphone, meaning that it has a lobe of listening in this direction and a lobe of listening in this direction, and it rejects sounds to the side. So in an ensemble setting, you do get some measure of isolation using a ribbon microphone because it's rejecting the sound coming from the side and primarily hearing the sound that's beneath it and above it. Now, the sound bounces around the room, obviously, and so the upper portion of the polar pattern is still going to hear the reflected sound in the rest of the room, but it is going to be rejecting the immediate sound coming from the sides of the microphone. You may need more isolation than that. If you need more isolation than that, you can use the technique of attaching a very small microphone to the violin itself. So I've attached another one of these tiny little lavalier microphones to the tailpiece here. It's right by the bridge. It's off of the body, so it's going to hear some of the resonance of the body. It's near the sound hole, so it'll hear some of the air movement in and out of the violin. And it's relatively close to the bow, so it'll hear some of the bowing. This is not an ideal position for a microphone, but in a setting where you're trying to get isolation from the instrument, a small compromise in the sound of the instrument itself can still allow you pretty good leeway with respect to the isolation from the other instruments. So I'm going to go inside and we'll have Susan play and we'll see what that sounds like. That sounded terrific. Thank you. Fifth string.
The fifth string? I don't
Is it for real? That's what it's called?
I mean, it's a
not
drum.
called like the singer or anything?
No, I don't, I mean, maybe.
This is Taylor Hales. He's the office wolf at Electrical Audio, but he's also an accomplished musician. And his instrument of choice is the banjo, or as we like to call it, the genius toothbrush. I just made that up. Tell us about your banjo and what differentiates your banjo from other banjos we might have seen.
So yeah, there's kind of a dichotomy where the traditional type of banjo that's played in a bluegrass setting is a resonator banjo, so it has this extra kind of wood appendage that rather than letting sound out of the back of the instrument, it projects sound, so sound bounces off of the resonator and it projects straight forward towards an audience. Open back banjos have no resonator, so there's sound that's coming from, that's emanating from the back of the instrument, so there's all this low end, like me the player, I'm hearing all this nice like rich low end that's coming through the back of the instrument up to me. And the open back banjo is more associated with the claw hammer, the old time style of playing, where or it's also called frailing, where you don't play with finger picks. It's generally a little bit slower, maybe a little less technical.
And it's the stoner's banjo, am I right?
Yeah, someone described old time banjo as like, as trance music, because you play the same like 8 or 16 or whatever, the same short tune just again and again and again, and it becomes like, it just becomes this kind of mantra.
That seems like perfect for an evening with the edibles, doesn't it?
Yeah, really fun playing open back banjo, really fun playing claw hammer and old time music, but probably not super fun to listen to.
So I know some banjos have 5 strings and some banjos have 4 strings, and there are even like guitarist banjos that have 6 strings. Yeah. What's the distinction and what's that 5th string all about?
Yeah, so the 4-string banjo is the tenor banjo, which is most commonly played, used to be played in jazz a lot, and now it's mostly played in traditional Irish music. 5-string banjo is played in kind of these 2 traditional ways that have evolved. It's bluegrass or 3-finger or Scruggs style. That's usually a resonator banjo, and then clawhammer, which is played on an open back banjo. There's also 2-finger. And then,
2-finger, that sounds even more stoned.
And then the 6-string banjo is really just like if you're a guitarist
and you want to fake it.
Yeah, and you want to fake it. And you get, like, banjo players know. Like, you're not fooling anyone.
Okay, so the top surface of the banjo, the membrane of the banjo, is essentially a drum head, or it's similar to a drum head.
Yeah, it is a drum head, and this is a Renaissance head, so you can get Renaissance heads for drums, and then you can get like a frosted head or a clear head, and they have similar tonal characters to drum heads. You can also get like real calfskin heads, and there's a lot of old time people there's a lot of really esoteric kind of rabbit holes.
The deep nerds of banjo.
Yeah, exactly.
So, and I noticed that there's some wadding inside the banjo. Is that normal, or is that just sort of an accommodation to a quieter style?
It's kind of we do have, a lot of us banjo players do have families, and we have to keep the volume at a family-friendly level. But it's also, it is also kind of common, especially for old-time players, to dampen the head of their banjo. It seems kind of like this, you're fighting a losing battle from the outset when you have this really resonant instrument, that the whole draw of it is just that these strings are singing the whole time, and then you're trying to dampen it. But it does change the sound of it, and it's just something that
And that's your default, as you normally play banjo, you'd play it like that, no matter what the setting was.
Dampening it? Yeah.
Okay.
Yeah.
So I've had to record banjo a number of times, and I've developed.
I'm sorry.
I was trying to get through this with with zero banjo jokes.
No, let's let them
We haven't
open the
told any
floodgates,
banjo
baby.
jokes. So I've developed a number of techniques. I learned fairly early that the singing portion of the banjo is the head rather than the strings. Like the strings obviously are exciting the instrument, and the bridge is exciting the head. But the majority of the sound, and certainly the volume, comes off of the head. So I found that having a microphone that favors the open portion of the head gives me a clearer and louder sound on the microphone than trying to squeeze a microphone in around where your fingers are. In this case, and to provide greater isolation, I've learned that I can take one of these tiny microphones and attach it to this area. It's hidden by this piece of gaffer tape, but I'll take it off and show you later.
He didn't.
But one of those tiny microphones is suspended between the strings coming off the bridge here, between the tailpiece and the bridge. Now, when there's nothing on these strings, this length of string is quite lively. And if you're just slamming away on the banjo, these are not tuned portions of the string, but they are singing. So you do hear this sort of an atonal jangle from these strings. But when I put this microphone in place, I asked you if it had a negative effect on the sound. You said that as far as you could tell, it didn't.
Yeah, I couldn't hear any difference with
Okay,
that piece
well
of tape there.
that's great news. I'm pleased to know that. I have experimented with, turn your banjo around, let people see the way it's built. There's this supporting bar that runs the length of the banjo. And I have experimented with attaching a microphone to the inside of this bar in an attempt to get the resonant sound from the head, but without interfering with the playing surface. And I found the sound inside the banjo to be quite dull and muffled and not very satisfying.
Yeah.
So there may be some secondary utility to having a microphone inside the banjo, but it's definitely not a solution to recording a banjo with isolation in an ensemble setting, because the sound of that microphone inside is just not that great. I don't know if you've had a similar experience, but owning a banjo, you probably put a microphone in there at some point.
Yeah, I've tried recording kind of the back of the instrument, and you do get like a little bit of low end, but by itself it sounds terrible.
Yeah.
So if you feel like you're lacking a little bit of low end, maybe sneak a little bit of that in there. But whether it's worth setting up a whole microphone just for that is it's open for discussion.
Okay, so I'm going to go into the control room, and we'll hear what these microphones sound like. There's this close microphone that's similar to the other isolation microphones we've used on the other instruments. It's a small lavalier microphone near the bridge, and then an external ribbon microphone. You're not going to be singing, but this microphone is in a similar orientation to the one we used on Rob.
I'm not singing.
I'm sorry, no. I don't know if you read the contract, but...
Okay.
Okay, so I'll head inside and we'll listen to you play some banjo.
Sorry.
So this is the crown GLM attached to the top surface of the banjo. And this is the 4038 external microphone. This is both. Now I'm going to add the ambient microphone. Again.
Oh, was that not long enough?
No, it was great. I just want to hear it again.
Those techniques are all useful for individual instruments, but often the instruments are playing as an ensemble, and the sound of the ensemble playing together is a big part of the experience. So let's have our friends play together as an ensemble, and we'll see what these techniques contribute to that sound. Okay, let's hear everybody all together at the same time.
1, 2, 3, 4. Iron, aluminum, steel, a pound will bring a penny or a quarter sometimes.
What are we going to wear to the Grammys? I hope this demonstration has given you some idea of how important it is to have a bunch of really expensive microphones.
Steve, the emails.
I hope this demonstration has given you an idea of the range of capabilities of using microphones on acoustic instruments, and given you some options to use when you need isolation rather than defaulting to the electronic sound of a pickup, but still achieve some degree of separation and isolation. But more importantly, I want you to remember that the experience of acoustic music is the thing that we all share. And the more realistic and more naturalistic your recording of it is, the more closely you recreate the communion of a physical, in-person, real event. That was pretty heavy. That was heavy, right?
Yeah.